Hello everyone. So in previous lectures, I taught linear programming problem. First, I taught formulation of LPP, then graphical method. Now in this lecture, we will see simplex method. So we have this question, solve the following LPP using simplex method. In this case, we have maximum objective function, maxima is z is equal to 3x plus 4y, and subject to constraint 2, first is 2x plus 3y is less than equals to 16, and second is 4x plus 2y is less than equals to 22, and non-negative constraints are x and y. So now we need to solve this problem with simplex method. So first we will convert these inequalities into equations. We will convert these inequalities into equations. So these are two inequalities. As this part is variable part, this part is fixed, and this is smaller and this part is greater. We can write this as this first part is smaller part and this part greater part. This is 16 and this is variable part. So this means this is fixed, we can't change in this. This is variable, so we can increase this part. So to equate these two parts, we need to add something in this first one, and this is considered as S. S is considered as slack variable. So as there are two constraints, both are less than, so first we will add S1 in first constraint and S2 in second constraint. Then this is equals to 22 and this is equals to 16. And same we will add in objective function as 0 into S1 and 0 into S2. We are writing 0 because there is no profit, no cost for these slack variables. These S1 and S2 considered as slack variables. As there are total 4 variables x, y, S1, S2, so we need to add all these 4 in subject to constraint also. So in this first constraint, we will include S2 in terms of 0 into S2 and S1 in this second constraint as 0 into S1. And non-negative constraints are now S1, comma S2, and both are greater than equals to 0. Now we can write this problem, these two constraints in form of Ax is equal to B also. So what is this B? This x is set of variables, and in this case we have set of variables like x, y, S1 and S2. These are set of variables, and this B is constant part. So this is 16 and second is 22, two constants, and this A is coefficient of these variables. So first variable x and constants are 2 and 4. So we can write this as 2 and 4. This is 3, comma 2 for y, and S1, S2, 1, 0. This is 1, 0 and 0, 1. So these are constant for these variables. Now we will prepare simplex table. So in this simplex table, we have different things. So first thing, basic variable. This B is considered as basic variable. So as we have total 4 variables, first is x, second is y, third is S1 and fourth is S2, we will write only slack variables x, S1 and S2 in this first block. And their coefficients in this objective function is 0, 0. So we will put 0 and 0. And these two equation equals to 16 and 22. So we will write B constant 16 and 22. And after that, we will write this Cj. Cj is coefficient in objective function. So this is the objective function, and in this objective function the coefficients are this 3 for x, 4 for y, 0 for s1 and 0 for s2. So we will write 3 for x, 4 for y, 0 for s1 and 0 for s2. So these are 4 variables with their coefficient. Now this part, this block x, y, s1, s2, 4 variables, and these are the coefficient in constraint, just like this 2 and 4. So this 2 and 4 for x, this 3 and 2 for y, and so on. Now we will do rest of the things. So we have this block, and now in this block this value is considered as z, and z equals to c into b. This c into b, c is this c 0 into 16 plus this 0 into 22. So this product, sum of product is 0. So in first case this c into b, z equals to 0. Now we will write these numbers. So if this is 3, then we will replace the sign, and now this is considered as minus 3, and this is 4. So we will write this as minus 4. This is 0, so 0. So this means we will replace all the signs of coefficient of objective function for this row. Now in this row, the most negative number is this minus 4. So for this minus 4, most negative number, we will say this as incoming vector IV, and we will put arrow on that. And these two elements in incoming vector, now we will use this 3 and this 2 as denominator for these ratio. And numerator term for this is this 16 and 22. So this is 16 upon 3. This is 16 upon 3, 5.33, and 22 upon 2, that is 11. So in these two numbers, the minimum number is this one. This is minimum number, minimum. This minimum number row is considered as outgoing vector. This is considered as outgoing vector OV. So we will replace this S1 by incoming vector by in new block. So we will replace this S1 by and coefficient of y is 4. This is the coefficient of y. We will write 4 here. And the intersection of this incoming vector and outgoing vector, this means this element. This element is known as key element. This is considered as key element. This is known as key element. Now to find this y row already calculated, we will divide this outgoing vector row, means this 16, 2, 3, 1 and 0 by this key element number 3. So you will see this as this number as 16 upon 3, 5.33, 2 upon 3, that is 0.67, this 3 upon 3 is 1, this 1 upon 3 is 0.33, this 0 upon 3 is 0. So now we have this element, this is the resultant of key element. For this element, above this element and below this element, we will put 0, 0, as we have 3 rows in this. So for these 3 rows, we will put for the second row 0, for this third row 0. So in this case, in this old block, this first is considered as old block, this is considered as new block. So for this old block, this first row is denoted by R1O, R1 old, R2 old, R3 old, and for this new one, R1 new, R2 new and R3 new. So now you have R3 new, all the values are there, but you need to find this R2 new and R3 new. So we will make formula for this R2 new and R3 new. So always this R2 new and R3 new will be based on self old. This means R2 old and this is also based on R3 old, it's old and existing new one. So we will consider this as R1 new and R1 new for both. This is existing new one. Now we will create relationship. So in this R2 new, first objective is to find R2 new. In this R2 new, we have one value 0. For this corresponding location, the old value is 2. This is plus 2. For this location, new one, this old location of R2 is plus 2. So we will write minus 2 inside it. So this is minus 2 into R1. If this is plus quantity, we will take minus. If this quantity is minus, then we will take plus. Now for R3 new. Now next objective is this. You have one value of R3 new, this is 0. So corresponding old is this minus 4. So we will take plus 4 here. So this is plus 4 into. Now we will find all these values by using this relationship. And one more thing, we can write coefficient of S2 as it is, as this is 0. So we will put 0. Now we will calculate from this. So to find this value and this value, all these values, you will use respective old. Old means you will use R2 old block. So R2 old block is this, and you will use existing new R1 new. So in this case, you will take, to find this value, you will use this first relationship. So in this first relationship, for this location old is 22. So we will put R2 old is 22 minus 2 into corresponding new is this one. For this location, corresponding new is this 5.33. So you will see this quantity as 11.33. So we will put this quantity 11.33 here, and in same way we will find other values. So again in this same formula we will put R2 for this location 4 and new is 0.67. Then we will find other values using this relationship. So this quantity is 2.67. This is, you will get 0 again, and this quantity is 0.67, and this quantity is 1 using this relationship. For each block we will use this and this quantity. To find this quantity we will use this one and its old quantity. So this is second row. Now we need to calculate Z. So value of Z is this into this, 4 into 5.3 plus 0 into 11.33. So you will see this value as 21.33. Now we will calculate this block and this block using this relationship. So to find this relationship, we will use R3 old. So R3 old is this row. So this is R3 old row, and R2 new, corresponding R2 new block, this value, and we will put values in this relationship. So for this first location, we will use respective old. Respective old is minus 3. So respective old is minus 3 plus 4 into, and corresponding new is this 0.67. So this is 0.67, and then you will get this value is minus 0.33. So this value is minus 0.33. In that way you can find this value using this value and this value, and you can find this one using this and this one. And on solving you will get these values as this is 1.33 and this value is 0. So this is the second block. Now again in this Z, just like this in Z, we have searched most negative value. Now in this Z, we will search most negative value, and this most negative value is this one, minus 0.33. So this is considered as out incoming vector OV, and these values 0.67 and 2.67 as denominator, 2.67 and 0.66, and these B values are numerator, so this is 11.33. On solving you will see this value is least value, and this is 4.25. now this is minimum in these two. This is your outgoing vector, this is outgoing vector, this is outgoing vector. This means we will replace this S2 by incoming vector X. This is incoming vector in new block. So we have replaced this S2 by X in new block, and Y still same. So we will put 4 coefficient of Y, and coefficient of X from this is this 3. So we will put 3 here, and this is the key element, intersection of incoming and outgoing. This is key element. Now we will divide all the elements of this second row by this 2.67. On dividing 2.67, you will see this quantity 11.33 divided by 2.67, then you will see this as 4.25 and this quantity as 1. Now this 0 upon 2.67 is 0, this 0.67 minus 0.67 upon this 2.67 minus 2.5, and this last quantity you will get 0.37. We have divided this second row by this key element number 2.67, then you will get these. Now for this resultant key element 1, we will put 0 above this one and below this one. Now we will say these rows are row 1 latest, R2 latest and R3 latest. So in these 3 rows you have already got this second one. Now your objective is to find this R1 and R3 on the basis of its old, on the basis of R1 previous means this new one, this second block. So R1 new and R3 new previous block values and existing this one. So we will write this one as R2L and this is R2L. Now we will make relationship. So first we need to make relationship for this R1, and for this existing value its old is this 0.67. So this its old is 0.67, this is positive value, so we will write minus 0.67, and for this one its old is minus 0.33, so we will write plus 0.33, and we will put values. So for this first row, for calculation of this, we will use its old. Its old means this first row values and existing new one, existing new one. So to calculate this value, we will use this, and new, and formula we will use this one. So R1 new value matlab means previous value. So previous value of R1 is 5.33 minus this 0.67 and its new is 4.25. So for this 4.25 and this, you will see this value as 2.49 something. So this is 2.49. By using again this relationship, using this value and this value, you will get this one, and in same way you can find others. So you will see this is 1, this is 0.50 and this is minus 0.25. And to find to understand more about this concept, how to find these numbers, I will share link of my another lecture on simplex in description. You can follow this link. And now we will find Z. So Z is equal to this C into B plus this C into B, and on totaling this, you will see this 22.69. Now using this relationship, we will find this last row. So to find this, we will use its old, means this one, and 0.33 or into this second one. So on adding this, you will see this term as 0, and on applying this relationship for this quantity and this quantity, you will see this quantity as 1 and this quantity as 0. So now you will see in this last row no negative value in x and y. So this means your problem is completed. Now we will identify values. So for y, this value of b is y equals to 2.49, and for x this value is 4.25. So x is equal to 4.25, and the maximum z value, this maximum z value is this one, 22.69. This is 22.69. So this is the answer for simplex. So I hope you understand this concept of simplex method. So please like this video and subscribe my channel Ganit Coach. And to find this, to understand this calculation part, you can follow my another link on simplex. Have a nice day. Thank you.